According to National Electrical Code Article 250.24 A5, the neutral conductor and equipment grounding conductor must be bonded together at the service and at each disconnecting point. In the described situation, there is no mention of this bonding occurring in the trailer panels. According to National Electrical Code Article 250.52 A1, a single electrode, such as a ground rod, is generally adequate for grounding a system. However, for extended systems, additional ground rods may be required. It is unclear whether the single ground rod is sufficient for the entire system. According to National Electrical Code Article 250.66, metal enclosures must be bonded together with a bonding jumper sized in accordance with Table 250.122. The use of a 2/0 copper bonding jumper is appropriate. However, as the ground rod may be insufficient, the bonding jumper may not be tied to a proper grounding electrode. The use of an armored cable with 3 hot conductors and a neutral conductor is permitted under National Electrical Code Article 330 and Article 396. The voltage of 230 volts to ground is consistent with National Electrical Code requirements for alternating current units and lighting. The grounding and bonding practices in the described situation present several issues that do not comply with National Electrical Code requirements and may pose safety hazards. Specifically, the neutral and ground are not bonded in the trailer panels. The grounding system may be inadequate, with only a single ground rod. The feeder conductor may need to be upgraded if additional ground rods are added. It is recommended to have a qualified electrician inspect the system and make the necessary corrections to ensure compliance with the National Electrical Code and safety standards. Let's delve deeper into each of these points. Firstly, the necessity of bonding the neutral and ground. The National Electrical Code mandates this bonding at the service entrance and at each subsequent disconnecting means. This requirement serves a critical safety function by providing a low impedance path for fault current to return to the source, thus facilitating the rapid operation of overcurrent protective devices like circuit breakers or fuses. Without this bond, a ground fault could result in elevated voltage potentials on metallic equipment enclosures, creating a shock hazard. In the context of the mobile home setup, the absence of this bonding within each trailer subpanel means that a ground fault within a trailer might not be effectively cleared, potentially endangering occupants. Secondly, we will consider the adequacy of the grounding electrode system. The National Electrical Code permits the use of a single grounding electrode, such as a ground rod, for grounding a system. However, it also acknowledges that for extensive systems, supplementary grounding electrodes may be necessary to ensure a low resistance path to ground. The primary purpose of a grounding electrode is to stabilize the voltage to earth during normal operation and to provide a path for fault current in the event of a ground fault. The question of whether a single ground rod is sufficient for the entire row of 6 trailers depends on several factors, including the soil resistivity, the length of the feeder conductors, and the potential for voltage drop along the grounding path. High soil resistivity can significantly impede the effectiveness of a ground rod, while long feeder conductors can introduce impedance that limits the flow of fault current. In such cases, additional ground rods, spaced at least twice the length of the rod apart, are recommended to lower the overall grounding resistance. To assess the sufficiency of the existing ground rod, it's advisable to perform a ground impedance test using a specialized ground resistance meter. This test measures the resistance between the grounding electrode and remote earth, providing an indication of the grounding system's effectiveness. A reading of 25 ohms or less is generally considered acceptable by the National Electrical Code, although low values are desirable for sensitive electronic equipment. Thirdly, the role of bonding jumpers in ensuring electrical safety. Bonding jumpers are conductors used to connect metallic equipment enclosures, raceways, and other non-current carrying metal parts to form an electrically continuous path. This continuity is crucial for providing a low impedance path for fault current to flow back to the source, thereby facilitating the operation of overcurrent protective devices. The National Electrical Code mandates that bonding jumpers be sized in accordance with Table 250.122, which specifies the minimum size of the bonding jumper based on the rating of the overcurrent protective device protecting the circuit. In this scenario, the use of a 2/0 copper bonding jumper appears appropriate for bonding the metal enclosures of the trailers. However, the effectiveness of this bonding jumper is contingent upon the integrity of the grounding electrode system. If the ground rod is inadequate, the bonding jumper will essentially be connected to a high-resistance path, which may not provide sufficient fault current to trip the overcurrent protective device in a timely manner. Now, let's discuss the acceptability of using armored cable as a wiring method. Armored cable, also known as Type AC cable, is a factory assembly of insulated conductors encased in a flexible metallic sheath. The National Electrical Code permits the use of armored cable for both exposed and concealed wiring in dry locations. However, there are specific requirements for grounding and bonding when using armored cable. The metallic sheath of the armored cable is recognized as an equipment grounding conductor, provided that it meets certain requirements. Firstly, the sheath must provide a continuous, low-impedance path for fault current. Secondly, the fittings used to terminate the armored cable must be listed for grounding purposes and must effectively bond the sheath to the metal enclosures. In this case, the use of the armor for grounding is permitted, provided that these conditions are met. However, it's crucial to ensure that the fittings used to terminate the armored cable are properly installed and that the sheath is not damaged or compromised in any way. Finally, let's examine the voltage considerations for alternating current units and lighting. The voltage of 230 volts to ground is consistent with the National Electrical Code requirements for alternating current units and lighting. In a 240 volt single-phase system, the voltage to ground is typically 120 volts, which is the voltage between either of the hot conductors and the neutral conductor. However, in some cases, 208 volt or 277 volt systems may be used for alternating current units and lighting. In these systems, the voltage to ground will be different, but it will still be within the acceptable range specified by the National Electrical Code. Given these considerations, it's clear that the grounding and bonding practices in the mobile home setup warrant a thorough review and potential correction. The absence of neutral to ground bonding in the trailer panels, the potential inadequacy of the single ground rod, and the reliance on the armored cable sheath for grounding all raise concerns about electrical safety. To ensure compliance with the National Electrical Code and to protect occupants from electrical hazards, it is strongly recommended that a qualified electrician inspect the system and make the necessary corrections. This inspection should include verifying the neutral to ground bonding, testing the ground impedance, inspecting the bonding jumpers, and assessing the condition of the armored cable. Any deficiencies should be promptly addressed to bring the system into compliance with the National Electrical Code and to ensure the safety of the mobile home residents. Furthermore, it's important to emphasize the importance of ongoing maintenance and periodic inspections of electrical systems. Over time, connections can loosen, corrosion can develop, and equipment can deteriorate, potentially compromising the safety of the system. Regular inspections can help identify these issues early on, allowing for timely repairs and preventing more serious problems from developing. In addition to addressing the specific issues identified in a mobile home setup, it's also worth considering the broader context of electrical safety in mobile homes. Mobile homes are often subject to unique electrical hazards due to their construction and the way they are typically installed. For example, mobile homes are often located in areas with unstable soil conditions which can affect the grounding system. They may also be subject to more frequent movement and relocation, which can stress electrical connections and wiring. For these reasons, it's essential to pay close attention to electrical safety in mobile homes and to ensure that all electrical work is performed by qualified professionals. By following the National Electrical Code requirements and by implementing sound electrical safety practices, it's possible to create a safe and reliable electrical system for mobile homes. In addition to the specific National Electrical Code articles mentioned, there are several other relevant sections that should be considered when evaluating the grounding and bonding system in the mobile home setup. Firstly, Article 250.32 addresses grounding requirements for separate buildings or structures. This article specifies the conditions under which a separate building or structure is permitted to have its own grounding electrode system. In general, A separate building or structure is permitted to have its own grounding electrode system if it is supplied by a feeder or branch circuit and if certain other conditions are met. However, there are exceptions to this rule, and it's important to carefully review Article 250.32 to determine whether it applies to the mobile home setup. Secondly, Article 250.50 addresses grounding electrode systems and specifies the requirements for different types of grounding electrodes. This article covers ground rods, ground plates, underground metallic water pipes, and other types of grounding electrodes. It also specifies the requirements for bonding different types of grounding electrodes together to form a grounding electrode system. Thirdly, Article 250.104 addresses bonding of piping systems and exposed structural metal. This article requires that metal water piping systems and exposed structural metal be bonded to the grounding electrode system to ensure electrical continuity and to prevent the development of voltage potentials. Fourthly, Article 300.3 addresses conductors of different systems. This article specifies the requirements for installing conductors of different systems in the same raceway or cable. In general, conductors of different systems are permitted to be installed in the same raceway or cable if certain conditions are met. However, there are exceptions to this rule, and it's important to carefully review Article 300.3 to determine whether it applies to the mobile home setup. In addition to these National Electrical Code articles, there are also several industry standards and best practices that should be considered when evaluating the grounding and bonding system in the mobile home setup. Firstly, the Institute of Electrical and Electronics Engineers Standard 142, also known as the Green Book, provides detailed guidance on grounding and bonding electrical systems. This standard covers a wide range of topics, including grounding system design, grounding electrode selection, and bonding techniques. Secondly, the National Fire Protection Association Standard 70, also known as the Standard for Electrical Safety in the Workplace, provides guidance on electrical safety practices for workers who are exposed to electrical hazards. This standard covers topics such as personal protective equipment, lockout-tagout procedures, and arc flash hazard analysis. Thirdly, the National Electrical Manufacturers Association provides a variety of resources on electrical safety, including technical bulletins, training materials, and product standards. These resources can be helpful for understanding electrical safety requirements and for selecting appropriate electrical equipment. By considering these National Electrical Code articles, industry standards, and best practices, it's possible to conduct a thorough evaluation of the grounding and bonding system in the mobile home setup and to ensure that it meets all applicable requirements. It's important to remember that electrical safety is a critical concern and that any deficiencies in the grounding and bonding system should be promptly addressed to protect occupants from electrical hazards. The role of a qualified electrician cannot be overstated in ensuring the safety and compliance of electrical systems, especially in unique environments like mobile home parks. Their expertise in interpreting and applying the National Electrical Code, coupled with their practical experience, makes them invaluable in identifying potential hazards and implementing effective solutions. Firstly, a qualified electrician possesses a comprehensive understanding of the National Electrical Code and its various articles related to grounding, bonding, and wiring methods. This knowledge allows them to accurately assess the existing electrical system in the mobile home park and identify any deviations from code requirements. They can determine whether the neutral to ground bonding is properly implemented, whether the grounding electrode system is adequate, and whether the wiring methods are appropriate for the environment. Secondly, a qualified electrician has the necessary tools and equipment to perform thorough testing and measurements of the electrical system. They can use a ground resistance meter to measure the impedance of the grounding electrode system, a voltage tester to check for voltage potentials on metallic equipment enclosures, and a circuit tracer to identify the path of electrical circuits. These tests and measurements provide valuable data that can be used to diagnose potential problems and verify the effectiveness of any corrective actions. Thirdly, a qualified electrician has the experience and expertise to safely and effectively perform electrical repairs and modifications. They can install additional ground rods, upgrade wiring, replace damaged equipment, and implement bonding improvements. They understand the importance of following proper procedures and using appropriate materials to ensure that the electrical system is safe and reliable. Furthermore, a qualified electrician can provide valuable advice and guidance to the mobile home park owner or manager on electrical safety best practices. They can recommend preventive maintenance measures, such as periodic inspections and testing, to help identify potential problems before they become serious hazards. They can also provide training to park residents on electrical safety awareness and the proper use of electrical appliances. In addition to their technical skills, a qualified electrician also possesses important communication and interpersonal skills. They can effectively communicate complex technical information to non-technical individuals, explaining the potential hazards and the necessary corrective actions in a clear and understandable manner. They can also work collaboratively with the park owner or manager to develop a plan for addressing electrical safety concerns in a cost-effective and efficient manner. In summary, a qualified electrician is an essential resource for ensuring the safety and compliance of electrical systems in mobile home parks. Their expertise in the National Electrical Code, their testing and measurement capabilities, their repair and modification skills, and their communication abilities make them invaluable in identifying potential hazards and implementing effective solutions. By engaging a qualified electrician, the mobile home park owner or manager can demonstrate a commitment to electrical safety and protect the well-being of park residents. It's also important to recognize that the National Electrical Code is not a static document, but rather it is continuously updated and revised to reflect new technologies, emerging hazards, and industry best practices. The National Fire Protection Association, which publishes the National Electrical Code, follows a rigorous process for developing and updating the code, involving input from a wide range of stakeholders, including electrical engineers, contractors, manufacturers, and regulatory agencies. These updates and revisions can have a significant impact on electrical installations, and it's essential for electricians and other electrical professionals to stay current with the latest changes. In addition to the National Electrical Code, there are also numerous other codes, standards, and regulations that may apply to electrical installations in mobile home parks. These may include state and local building codes, fire codes, and environmental regulations. It's important to be aware of these additional requirements and to ensure that all electrical work is performed in compliance with them. The cost of hiring a qualified electrician to inspect and repair the electrical system in a mobile home park can vary depending on the scope of the work, the complexity of the system, and the location of the park. However, it's important to view this cost as an investment in safety and compliance rather than an expense. The potential consequences of neglecting electrical safety can be far more costly, including fines, lawsuits, property damage, and even loss of life. Furthermore, by addressing electrical safety concerns proactively, the mobile home park owner or manager can improve the overall value and attractiveness of the park, attracting new residents and retaining existing ones. In addition to engaging a qualified electrician, there are several other steps that the mobile home park owner or manager can take to promote electrical safety in the park. These include providing residents with electrical safety information, conducting regular inspections of electrical equipment, and promptly addressing any reported electrical hazards. By creating a culture of electrical safety, the mobile home park owner or manager can help protect residents from electrical hazards and ensure the long-term reliability of the electrical system. Finally, it's important to remember that electrical safety is everyone's responsibility. Residents, park staff, and visitors all have a role to play in promoting electrical safety and preventing electrical accidents. By working together, we can create a safer and more secure environment for everyone in the mobile home park.